Today we are starting out looking at our number systems. At this point, most of what we have done are real numbers. Oops, sorry. Okay, the real numbers are all we have worked in so far. They include the natural numbers. Okay, our natural numbers are our counting numbers. Okay. These are our counting numbers, 1, 2, 3. If you start to count, you naturally start at 1 and count by whole numbers. All right? Once we take our counting numbers and we add the 0 right there, when we add 0, they become whole numbers. So all of our natural numbers are also whole numbers. Then when we add our negatives, numbers, they become integers. And when we add our fractions and our decimals, we start looking at rational numbers. Now, the thing to remember here, and you can't see it real good on this picture, the rational numbers are terminating or repeating. Ooh, that didn't go well. Or repeating decimals. Okay? Now what that means is that terminating means it stops. So 3/4 is the decimal 0.75. It stops. We don't have to round it to get it to stop. Okay? Now, a repeating decimal would be something like 0.33 repeating, or 0.676767, and yes, those are sixes, sorry. Okay, so those are terminating and repeating decimals. You need to make a note of that on your organizer because that's not real easy to see here and we didn't have any examples. Okay, so that becomes our rational numbers. Now what I want to point out is the irrational numbers over here, they are the non-repeating, non-terminating decimals. The most popular example of that is pi. Because remember, pi, they still haven't found the end of it. I think they've got it out to like, I don't know, maybe 1 million decimal places, and it still does not have a pattern that completely repeats over and over. Obviously, it repeats some numbers because there's 1 million digits, but the pattern does not repeat over and over. All right, so be sure that you fill out your own organizer, make whatever notes you need to. So those are our real numbers. It's all you've ever worked with. Okay? And I'm going to erase all of this, actually. Okay. Now, you may be saying, what else is there? Well, the opposite of real is imaginary. Imaginary numbers. Now, what you can't see very well right here, the square root of -1 will from now on be referred to as I. Now up to this point, we just didn't deal with the square root of negative numbers. It wasn't possible. And positive times a positive is a positive, and a negative times a negative is a positive. So the square root of a negative number was not possible. Now it's going to be possible. So we are going to look at how I's work in our number system. Now, when we take real numbers and imaginary numbers together, they make complex numbers. Now, all real numbers are complex numbers. All imaginary numbers are complex numbers. Why? Because both sets are inside our complex number circle. Okay? Now, complex numbers can all be written in this form. I'm going to write over what's on here just because you can't see it. Well, actually, can I zoom in? No, I can't. A plus BI. All complex numbers can be written in that form. The A is the real part. The BI is the imaginary part. Okay? Now, if you'll notice right here, real numbers can be written in the form A plus 0I. So the 0 makes the imaginary part go away, and now it's just a real number. Imaginary numbers can be written in the form a plus bi or 0 plus bi. So it might not have a real part. So in this situation, this is called a pure imaginary number. Okay. Now be sure that you get this organizer, because on the back of it is a review of your exponent laws, and they will be helpful as we go through this. All right, let's explore imaginary numbers. All right, as we said before, I to the 1, equals the square root of negative 1. Now, anytime we need to deal with the square root of negative 1, we are just going to use an I. Okay? I squared, well, that means the value of I times itself. Okay? Well, that is the square root of negative 1 squared. And remember that the square root and a square are opposites of each other, so they, for all practical purposes, cancel each other out, and we're left with a negative 1. So we have I to the 1 equals I squared equals negative 1. Okay, I to the third, that does not look like a 3 at all, does it? I to the third, we can break apart as I squared times I. Well, we just said that I squared equaled negative 1 times I to the 1, which gives me negative I. So I to the third equals negative I. I to the fourth, we can break apart into I squared times I squared, because I squared times I squared equals I to the fourth. We know that I squared equals negative 1. I squared also equals negative 1. Negative 1 times negative 1 equals 1. Okay, let's go ahead and do I to the fourth, or I to the fifth, sorry. That's the same thing as I cubed times I squared. Well, we've just said that I cubed equals negative I. I squared is negative 1. Negative I times negative 1 gives me a positive I, because a negative times a negative is a positive. So I to the fifth equals I. I to the sixth is the same thing as I cubed times I cubed. I cubed equals negative I. I cubed equals negative I. A negative and a negative is a positive. I times I is I squared. Sorry, that looks like a J, I know. I'm writing at an angle here. But what did we say I squared equaled? Negative 1. So I to the sixth equals negative 1. We'll do two more. Just want to be sure that you're understanding exactly how we are finding these values. I'm going to break I to the seventh down to I to the fourth times I to the third. I to the fourth is 1. I to the third is negative I. And 1 times negative I is negative I. So I to the seventh is negative I. Last one. I to the eighth equals, got to get better at these I's. I to the eighth, I to the fourth times I to the fourth. I to the 4th equaled 1, I to the 4th equals 1, and 1 times 1 is 1. So I to the 8th equals 1. So what I'm going to do now is I'm going to make a table with all of these values. I to the 1 equals I squared equaled, if you look back up at your table, negative 1, I cubed equaled negative I, and I to the 4th equaled 1. I to the 5th equaled I to the 6th equaled negative 1, I to the 7th equaled negative I, and I to the 8th equaled 1. If we kept going, what do you think would happen? Do you notice the repeat? Okay, so I'm going to assume that I to the 9th is also going to equal I, because everything on this row is equaling I. I'm going to assume I to the 10th is going to equal negative 1. I to the 11th is going to equal negative I. And I to the 12th is going to equal 1. So you can finish filling this out. Alright, so what we're seeing here is a pattern. Now, what that pattern tells us is that every 4th cycle, or every 4 exponents, we repeat a cycle. So what we're going to look at is, what if we had I to oh my gosh, my writing's getting bad. Sorry, guys. I to the 43rd. Okay? Well, I to the 43rd, I could do 43 divided by 4. 4 goes into 4 one time. 4 won't go into 3, so it has a remainder of 3. Well, watch what happens. If I did the same thing with everything in this column, 13 divided by 4, we know that it equals I. 4 goes into 13 3 times, that's 12, has a remainder of 1. We know that equals I. So what we see here is that a remainder of 1 is going to give us I. Okay, now I'm going to erase this. Let's look at the next one. Let's look at 14. 4 goes into 14 3 times with a remainder of 2. Well, 14 equals negative 1. Everything with a remainder of 2 is going to equal negative 1. Okay, I'm going to erase that. How about 15? 4 divided into 15 goes 2 times. 3 times, sorry. 3 times. 3 times 4 is 12. Leaves a remainder of 3. We know that is negative I. So a remainder of 3 equals negative I. So what that tells me is that I to the 43rd, since it has a remainder of 3 when divided by 4, equals negative I. Okay, so let's go ahead and do I to the 16th. 4 into 16 goes 4 times. Well, it has a remainder of 0. So instead of looking for a remainder of 4, we're looking for a remainder of 0. Now, I know that you guys don't necessarily use or do long division anymore. So, I want you to understand that if you put it in the calculator, if you did 13 divided by 4, you would get 3.13. 0.25. So the decimals on the calculator, of 0.25 will equal I, 0.5 will equal negative 1, 0.75 will equal negative 1, and no decimal means it equals 1. Okay, so I to the 21st. Okay, 21 divided by 4. Remember, we're always doing it by 4 because that's when the cycle starts over. 4 goes into 21 5 times. That's 20. I have a remainder of 1, but if you put it in the calculator, that is actually going to give you 0.25 as you multiply this out. That decimal of 0.25 means that I to the 21st equals I. Okay? Now, to start simplifying, we're just going to touch on this just a little bit in this section. In this video, we're just going to introduce it. First thing that I want you to know is that when we are simplifying complex numbers, we follow our order of operations. And remember, that is PEMDAS. Oops, didn't mean to move that, sorry. PEMDAS, which is parentheses first, if we can simplify what's inside them. Then we do exponents. Then we do multiplication left to right. And then we do addition and subtraction left to right. Okay? Alright, now we have a new little rule where where imaginary numbers are concerned. This rule is called the principal square root of negative numbers. Now what this says is that if we have the square root of negative n, that equals I times the square root of n. Okay, so what we have done is we have taken the negative sign and we've pulled it out as an I, and that leaves the n underneath the radical sign. Okay? Now, what does that mean in terms of actually working a problem? Well, the correct way, let's do blue, to work the following problem: the square root of negative 4 times the square root of negative 4. The principal square root of negative numbers says that before we start combining anything, we've got to get rid of the negatives underneath the radical signs. Okay? So, I'm going to rewrite this as negative 1 times 4 times the square root of negative 1 times 4. The negative 1's I am going to pull out as I square root of 4 times I square root of 4. Okay, so what is the square root of 4? The square root of 4 is 2, but we've got this I out here. The square root of 4 over here is 2 with its I. Now what is 2 times 2? 4. And what's I times I? I squared. But what is I squared equal to? Oops. I squared, we just learned, is equal to negative 1. So negative 4 is our correct answer. Okay, this is the correct way to use it based on the principal square root of negative numbers. Now let's look at the incorrect way to work this problem. The square root of negative 4 times the square root of negative 4. Well, we know we can multiply those following our radical rules. So if you decide to put them under here like that and multiply before you pull out the negative number, or the negative signs, you get the square root of positive 16, and the square root of positive 16 is 4. Notice, not equal to each other. This one is not correct because it did not follow the principal square root of negative numbers of pulling the negatives out first. Okay? All right. Your homework, for those of you in my class, find the value of I to the 93rd. Find the value of I to the 206. Find the value of I to the 400. That is a 0. And last but not least, a little review for yourself. Find the value of square root of negative 75. All right. Enjoy.